I think sometimes people put their hands up and they're like, there's no way we can get really high reliability for autonomous agents. And I think this really isn't true because if you look at cloud infrastructure, there's inherent unreliability across the stack. And yet we've been able to engineer systems through redundancy and all sorts of other engineering best practices to be able to get really, really high reliability. What I'm really excited about is how can we build those same things for agents.
Hi, I'm Rachel Chalmers, and this is Generationship, the podcast at the intersection of infrastructure and artificial intelligence. We are the generation that's exploring generative AI. We are a finite group of people with a finite set of resources, and we have to share this infrastructure. We have to find fair and ethical ways to do that. The first generation ship has already set sail. It's the planet Earth, and you and I are the crew. This show is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com. Today, I'm delighted to have Brooke Hopkins on the call. Brooke is the founder of Coval, a simulation and evaluation platform for AI agents. She previously led evaluation job infrastructure at Waymo. And if you're in San Francisco and you haven't taken one of the robot taxis yet, you have to. It's so science fiction. It's amazing. Brooke's team was responsible for the dev tools for launching and running simulations, and she engineered many of the core simulation systems from the ground up. She has a Bachelor of Science degree in Comp Sci and mathematics from New York University. Brooke, it's so great to have you on the show.
Thank you so much for having me, Rachel.
Super excited. How is testing voice AI agents different from testing traditional software? And how does it compare to your experience testing the AV driving models at Waymo?
Yeah, so when I was at Waymo, I think I spent a lot of time building out these simulation and evaluation tools for how we can test and create really reliable self-driving cars. And when I left Waymo, it felt like there were so many similar problems happening in the rest of the industry in AI that weren't just AV specific. But how do you take really large data sets and find interesting examples within those data sets and then test non-deterministic models? So being able to run the same examples over and over to get some probabilistic output, and then taking all of those insights and being able to make sense of all this data in a way that you can draw conclusions about how your system is performing. And these are all the same problems that are happening in AI. Especially with voice, how do you run voice agents so that from point A to point B, like let's say a customer support ticket, how do you make sure that that customer support ticket is being handled correctly every single time, even in lots of varieties of scenarios and circumstances, and how that person responds, if there's background noise, and all of these other attributes. And so this is really similar to self-driving cars because in the same way that when you're driving down the street, you might come into the same intersection every single time, but there's always going to be these slight variances. And so we're taking the same approach of robotics and self-driving is how can you take these simulation best practices and apply them to voice and chat agents and eventually other agents that are navigating the external environment to be able to produce really reliable autonomous agents.
So the car needs to get from A to B, even in this very challenging and changing environment, without killing any pedestrians. The customer support agent has to get the customer the right answer, even though the customer themselves is discussing the problem in different ways and really complicated. And the way you do that is you run 1,000 simulations and you try to get the bad outcomes down below 0.1%. Is that right?
Exactly. I think that the big difference between traditional software engineering and agent or non-deterministic models development is that for the same input, you might get lots of different outputs. And so a test where you say, for this input, I expect this exact output, those tests no longer make sense because really what you care about is how often am I getting it right across a slew of use cases. And for some cases, like that reliability needs to be super high. And so similar to cloud infrastructure or these other places, you might want 6 nines of reliability for those.
Please don't kill any pedestrians.
Exactly. Or definitely want to be compliant or want to make sure that we're getting this answer right every time, even if it means sometimes we don't serve it autonomously. And then on this other side, there are some cases where actually just any response is okay, and you might have a lot lower reliability requirements. And so I think being able to find the in-between between all of these is super important. So it's not just is it getting the right input for this one instance? It's what's the probability across all of my simulations?
So those are the big differences. What engineering principles from traditional software dev still apply versus the ones you've had to completely rethink?
Yeah, I think sometimes people put their hands up and they're like, there's no way we can get really high reliability for autonomous agents because they're non deterministic and we'll just never be able to control the models. And I think this really isn't true because if you look at cloud infrastructure, that's a great example from traditional software engineering where there's inherent unreliability across the stack, right? Like everything is unreliable from the servers, from the network layer, all the way up to the application layer. There are so many layers of reliability that theoretically, if you compound all of those, you would basically get no uptime. And yet we've been able to engineer systems through redundancy and all sorts of other engineering best practices to be able to get really, really high reliability, like 6 nines of reliability. And so I think what I'm really excited about is how can we build those same things for agents where you're not just relying on a single call to an agent and if it fails, then it falls over. But how can we start thinking about, for example, like fallback mechanisms so that when an agent fails to complete a task, like can it retry or can it have another agent that's helping to check those answers? And people are already doing this today with guardrails. Like, can we have checks as it goes along? Throughout the task, like have some checks to double check those answers with smaller models or more expensive models, et cetera. And then at like a more fundamental layers, like can you have multiple calls so that you're like double checking work, et cetera. And so I think taking some of those principles of how do you create redundancy and strong fallback systems in a fundamentally unreliable system to create reliability is super interesting. I think also testing best practices in many ways have dramatically changed, but in many ways they're still very similar, where you want to have unit tests, you want to have some integration tests, you want to have like a testing pyramid of these are all my base cases, these are all my edge cases, and running variety of like small tests to iterate really quickly, and then large tests to be able to test your system end to end before big releases.
I love using the SRE and platform engineering world as a sort of example of how to deal with uncertainty and the messiness and chaos of the real world. It seems like a really powerful analogy for what you're doing.
Totally. I did a lot of SRE work at Waymo. And so I think there it's like really exciting to do like reliability work because you have all of these non-deterministic models across all of the stack and being able to like jump into any problem and say like from first principles, like what's going on here. There's something really thrilling about that.
We live in a chaotic and messy world, but mathematics and statistics give us a really powerful way of thinking about it. Meanwhile, the voice AI market is evolving at just an incredible rate. Now that you're at Coval, how are you helping companies keep up with this rate of change?
Yeah, I think it's been really crazy since we started back last summer. There were very few people doing voice. I think the models weren't yet good enough. It was still extremely early in terms of every layer of the stack. The speech to speech models didn't even exist. The ability to do text to speech and speech to text, and then also the reasoning capabilities of these models were just much farther behind than where they are now. And so I think this explosion of voice has been really exciting, but it also feels like things are moving so fast where every week there's a new thing that's happening in AI. So, or in voice AI. And so a question we get from our customers a lot is like, which parts of the stack should I be looking to switch at? Which parts of the stack should I just like keep and assume that it will continue to get better? And I think this is where having really strong evals is super important. Like Gary Tan said that the foundation of really strong agentic systems is actually in how strong your evals are. And the reason for this is I think because you're able to swap out these different modules as things improve so that you can move really fast with the rest of the market. So when the next best voice model comes out, you can throw that in your system, see how well it performs with your use cases, tune it, and ship that really quickly. Whereas if you are in the dark of how your voice agents are performing, it becomes really hard to swap out any one piece because everything is so brittle. And I think this is true with prompts. When you change to different LLMs or different reasoning capabilities, it's going to be a lot harder to try out these new experimental models if you don't have the evals and the baselines to compare that against.
Because you're quantifying the performance of all of these different stacks and models, you're in a position to advise your customers on what's actually working with some objective backup to it. That's a very cool place to be.
Totally. And I think you also have the ability to experiment. I think some of the companies at the forefront of voice agents are there because they're constantly trying out new architectures. They're constantly trying out different ways of doing it. One of our customers who is like, I think we pair a lot on not just how should they set up their evals, but how can they run experiments of these novel voice architectures to see how it compares across against their baseline. And this is changing like every month. They're thinking about new ways of doing these things. And so I think at that rate, it's just really hard to compete in the market if you're not also iterating at that speed.
So we're ending up with these stacks that are going to be very dynamic, and people are going to be reassembling them from different components as new capabilities come online. How do you design dev tools that can remain relevant through all these transitions?
Yeah, I think the beauty of doing the testing aspect is that even if we get to AGI, what we're doing is we're saying, are you achieving the outcomes that you're looking to with your autonomous agents? And so it's less about any of the specifics of different parts of the stack. If you're using speech to speech, and in cascading architecture, that's using speech to text, and then using an LLM, and then text to speech, and kind of iterating through that loop to respond to your user. And that can be compared with speech to speech. And I think here we're seeing, even in all these different cases, you're still ultimately trying to get back to your user as fast as possible. And so I think even as we evolve into web agents or as we evolve into these other autonomous agents, it's going to be a very similar process in the sense that you're trying to evaluate the ultimate outcome. And so as the tools shift under you, the key is to just, I think, obviously staying up to date and that being in tune with the latest that's happening in agents and the best practices, et cetera. But I think we have it a little bit easier there. Whereas I think the models definitely are just constantly changing. And if you're not constantly releasing the best model, the market moves so fast.
So what metrics do matter the most when you're benchmarking voice AI systems, and have those changed since you started Coval?
Yeah, I think they definitely changed over time. I think even starting with more traditional NLP metrics now are no longer useful just because the models have become so good. So for example, like Blue and Rouge or some of these other academic benchmarks that have been used for a long time in benchmarking NLP models, those no longer are super useful for being able to say like how accurate or like conversational an agent is. And then similarly, there's a lot of other things like, for example, word error rate is very common around measuring text-to-speech models, or latency is obviously a big consideration. But I think beyond that, we're actually now seeing like the frontier of what people care about constantly shift. So in the beginning, people were just thinking about like, can it respond to the user with a relevant response? Like basically, can it have a natural conversation for a prolonged period of time without forgetting who the agent is and where in space they are?
Can it pass a Turing test?
Yeah, exactly. Like, can it just have a conversation back and forth? But now I think we're seeing people like they're saying, can it follow this really complex workflow? Can it call all of these tools and make function calls in really intelligent ways? I think other things that we see come up a lot are, can you say emails or phone numbers or complex alphanumeric strings? These are all super difficult to nail because the cadence at which you say different numbers matters depending on the context. And then I think also being able to tune, and this is a metric that we don't yet have, but I think we're working on some exciting things around how do you tune how casual or formal an agent is? So being able to create the user experience around these agents. So for some agents, you want them to be much more professional or rigid, whereas other agents, you want them to be much more casual and human-like. And so you can add in things like disfluencies around saying like, all the things that make me sound really human. And then you can have these very professional agents. Like if you're an airline, you're obviously going to want it to sound very professional, be it like web agents or voice agents, chat agents, like all of these different modalities, you're going to want to create a different brand and a different tone.
Yep. Teach the voice agents how to code switch.
Exactly.
How do you think about creating standardized benchmarks in a field where every company seems to be measuring success differently?
Yeah, this is something that we're really excited about because we get this question from customers so often, which is like, which parts of the stack should I be using? We've actually started to do benchmarking across lots of different models. So for example, with text-to-speech, how can you think about which text-to-speech provider to use, like running continuous latency, word error, and other benchmarking for those. I think something that's really missing from benchmarking right now is the continuous aspect. So being able to go and say, like, what is the latest for all of these different models on a continuous basis? Like over the last week, how reliable were each of these models? Can I compare how these different models sound for my different use cases? And so that's something that we're kind of investing some time on to do that both for ourselves of how can we be able to determine which ones we should be using internally or help our customers decide that. And I think it's also just like a huge need right now is there's so many models coming out all of the time, like to be able to choose between these. I think voice right now is pretty underserved in terms of benchmarking capabilities.
What unique challenges have you encountered building dev tools specifically for voice AI companies? What surprised you?
Yeah, I think we went into it thinking that there are a lot of similarities with self-driving. And I think that has proved even more true than we expected around just I think there's a couple of like really core fundamentals emerging from self-driving robotics and now autonomous agents that I think we're going to look back on as kind of this new era of software engineering best practices. I think similar to web or object-oriented programming or like kind of web architecture and web interface architecture. I think we're going to start to see like what agentic and non-deterministic AI systems, how they should be architected and what those look like. I think in self-driving, there emerged a really common architecture across all the companies around perception, so perceiving all of the inputs of the different sensors on the car, behavior prediction, which is given all of these different inputs of like, this is a pedestrian, this is a car, etc. What do I think all of the objects in the scene are going to do next? And then planner is based on all of these inputs. What should the car do next in order to achieve its goal of getting to point B? That's obviously oversimplified, but I think there's a lot of commonalities between all of the different self-driving companies. And then on top of that, also like how you simulate and how you deploy software here, there are a lot of learnings there. And so I think we're going to continue to draw on those learnings. And self-driving is used as an example, I think increasingly so in autonomous agents for that reason, because it's a great trend line to draw between all of these different non-deterministic agents. How do we start to emerge like a new software engineering deployment practice for these new systems?
So sort of along the lines of those emerging standards from the autonomous driving companies, how do you balance the needs of different stakeholders within the voice AI companies? You've got your ML engineers, you've got your product managers, you've got your QA teams. How do you make sure everybody's needs are met?
Yeah, I think this part is actually really exciting because as AI is kind of upheaving all these different roles within companies, I think a lot of times people are talking about like PMs and engineers are emerging or different roles are changing so dramatically. I think we're seeing that the line between developers, PMs, or developers and sales is closing as well. So for example, when you're buying an agent, you can't just assume all the buttons work, right? With traditional B2B SaaS, you didn't have to like go into the dashboard and be like, okay, you say that you track all my applicants, but do you actually? Like, let me go check. And with agents, you totally have to do this because the difference between a really highly performing agent and a poorly performing agent means whether or not it's useful or not. I think a lot of these agents, obviously you would love for an agent to be able to close more sales for you or handle all of your customer support requests. But if it's not actually doing that for 90% of them, then it's actually just creating a lot of noise. And so I think that a lot of these roles are going to change where software engineers actually have to provide a lot of these low-level analytics or insights into how well the agent is performing in order to convince customers that their agents are behaving as they expect. And vice versa, I think as a company procuring agents, how do you think about that buying process? And how do you think about like what questions should you even be asking as a CTO? Like, should you be calling an agent over and over? I think that with Coval, like what we really want to do is be able to provide a framework for how people can think about these questions.
Brooke, you've convinced me. I'm going to make you God Emperor of the solar system. For the next 5 years, everything goes the way you think it should go. What does the world look like in 5 years?
I think we're much more creative And we have space to build so much more. I think in general, over time, humans have become more creative with every new technology advancement. And I think that's overwhelmingly apparent with AI. People are building software who never could have built software before because you have things like Lovable or Bolt.new to be able to just spin up applications out of nowhere. And then on top of that, you have the ability to do all this amazing design work, or being able to put words to thoughts that you had and maybe just weren't able to bring together cohesively. And so I think I'm really excited about just how creative it will make us.
And now, to test your creativity, if you had a colony ship to the stars, if you had a ship that was going on a 100-year journey, what would you name it?
I love this question. Is it inspired by Generationship?
Yes, exactly. That's where we get the name from. The idea that the journeys that we make will take more than one human generation to survive.
I love that. Well, I would have to name it Sophia because we're named after Sofia Kovalevskaya. And she was the first female mathematician to get her PhD. And then Coval is also conversational evals. And so we're definitely named in her honor. But I think that this idea of being at the forefront of your field and being the pioneer obviously fits so well with being a generation ship too, in many ways. So I'll have to name it Sophia.
And of course, Sophia is wisdom, and wisdom is going to get us to the stars if nothing else does. Thank you so much, Brooke. It's been a delight to have you on the show. Come back anytime.
Thank you so much, Rachel. It's been great to chat.
That's all we have time for today. If you're interested in being a guest, or if you know someone awesome I should interview, hook up with us online. We're available where all fine social medias are sold. This show is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com.